This is an example of using the TDR system on a 9000 series sampling oscilloscope to measure the impedance of a 75 ohm and 50 ohm cable. So I'm going to go ahead and select the TDR menu, turn on TDR and select TDR channels. So there are two generators provided on the instrument on the rear panel, so I'm going to use generator 1 as this is the specially selected generator with a fast edge. In fact, the edge is 100 picoseconds, and this defines the maximum resolution available on the instrument, which is twice the rise time, so it can measure events which are spaced down to 200 picoseconds. So I'll select generator 1, and here we can see generator 1 now is on. It's generating a negative step at the rear panel, and I have then connected a 50 ohm cable to the front panel, and this is at the front panel at the T-piece, and this is my reference plane. So I'll just change the display to vectors. So here we can see the edge at the rear panel again, the 50 ohm cable and my reference plane. I'll just turn on some averaging to increase the accuracy of the measurement, so I'll just put in a little bit of averaging, and I'll increase the record length to the maximum 4096 so we can get the best resolution in the horizontal plane. So the first thing I have to do now is to calibrate the TDR system. So I'll select TDR and I'm going to select calibrate, and it asks me to connect a 50 ohm to the reference plane cable. So the 50 ohm cable is now connected. Select OK, and this will go ahead and perform calibration. Then the prompt is to disconnect the 50 ohm reference. Select OK, and this will complete the calibration procedure. This then calibrates the baseline and the amplitude, and these factors then can be recorded. So select OK, and we've updated. So the system is now calibrated at this point to measure any unknown impedance. So I'm going to connect, as my first example, a 75 ohm cable at my reference plane point. And here we can see the equivalent voltage of the TDR system for my 75 ohms cable. In fact, we can just detect a secondary image here, and all TDR systems will display a multiple reflection and give you a secondary image. The vertical scale is on voltage. I'm going to select now ohms, so this is directly calibrated in ohms, so we can see channel 1 now is 20 ohms per division, and I've got a 0 offset. So I can just pick this waveform again and drag it, and that has changed the offset value. So here is my unknown impedance, my 75 ohm cable, so I could measure this with a cursor. So I'll turn on a marker, turn on the Y marker. So here now I have two markers available, so I'll select this one, place it on that point there, so we can see my marker 1, now the mean value of this cable as an impedance of 67 ohms. This is the output going to a very high impedance, so I'm going to connect, as a second example, a length of 50 ohm cable to the T-piece at this point. So collect my 50 ohm cable, just clear the display, and here we can see now 75 ohm cable and then some 50 ohm cable, so I could put my second marker on that point and see here that it's indicating this cable as a mean impedance of 55 ohms. As a final example, at the T-piece now I'm going to put in parallel a second piece of 50 ohm cable in parallel with the first piece. Obviously the effect of that is to lower the impedance. 250 ohms in parallel will give me an impedance of 25 ohms. So here I can move my cursor down now, and indeed the parallel of those two pieces of cable gives me an impedance of 29 ohms.